So indeed, as politicians would say, Artemis is the name of this program. I approve this message. We are going to the moon and to Mars. Yeah. And of course, all of you have been around us, Explore Mars, or even before that, know that this Artemis has changed allegiance from the moon to Mars decades ago. So it's a good thing that we're still going to Mars. Now, beyond Apollo, 50 years ago, the moderator of Next Panel, John Logsdon, was actually present when the Apollo 11 was launched. How's that for being really dedicated to space? While you're, 50 years later, you're still moderating a panel, you're still at it, and you're still fighting for humans to get back out there in space, permanently, please, and also, make it with a more wider group. Because I agree with Jim Bridenstine as a European. The next mission, human mission, to the moon and to Mars cannot be an all-American party. The Europeans, the others, they have to step up, they have to work together, or I, as a European, a citizen from another part of this planet, will feel very disappointed. Never mind that you Americans go for all humankind. We would like to be with you. And anyway, so John Logsdon is himself, like I said, has been doing this thing for 50 years. He's still dedicated. He has a great panel, and he's going to show us, or tell us, or whatever, can the 2024 moon landing enable a landing on Mars? Do you still know the date? 6th of October, 2033? Oh, and I still know that I might be a bit, optimistic. It could be the 21st of October. You never know. John?
Good morning. My job is basically to get us on the stage on time and off the stage on time and give my panelists a chance to speak. Let me introduce each of them briefly, and then we'll start. Ryan Whitley is the Director for Civil Space of the National Space Council. He comes to Washington from the Johnson Space Center, where he's been employed from 2001. He's very proud that he designed the rectilinear halo orbit that the Gateway shall be in, and is a trajectory expert. Ken Bowersox is the Deputy Associate Administrator for Human Exploration and Operations at NASA headquarters. Sox is a veteran of 5 shuttle flights and a space station expedition. He was on the first shuttle repair mission in 1993 and dabbled into the new space world after leaving NASA and now is back. Rob Chambers is the I think relatively recently christened Director for Human Spaceflight Strategy and Business Development at Lockheed Martin, and is here to give us an existence proof that this can be done. Bhavya is a PhD from George Washington University. I have to get the commercial in, and a senior researcher at the Science and Technology Policy Institute. I'm willing to bet most of the people in this audience don't know what the Science and Technology Policy Institute is. Bhavya is going to tell you a little bit. But it's an organization that's raising its profile in the Washington space policy world. So, Ryan, you're first.
Thanks, John. Can you hear me? Okay, excellent. Happy to be here at the Human to Mars Summit, and after following Jim Bridenstine, it's going to be a hard measure to do that. But he outlined some important things that I think I want to talk about as well, and that's related to what the Space Council is up to in the space policy directives. So I think, as we all know, about 2 years ago, the Space Council was started again, is new again. And one of the first things that happened was Space Policy Directive 1, which Jim alluded to. And it does talk about Moon and Mars, and that's key. Sustainable operations into Moon and Mars with international commercial partners. So after that announcement came in about December 2017, the Space Council turned to some other issues in the broader space community, including deregulation, space situation awareness, and even Space Force. So Space Council covers a broad breadth of topic areas, not just NASA. But then this spring, there's a return focus to NASA. And so folks, you may have heard in March a big announcement by the Vice President, and some folks are wondering, how that kind of came about. And really it came about because the Vice President is very passionate about deep space exploration, and same with the President. There's this big interest in seeing this succeed. And so when they saw the budgetary request for 2028, and they saw that come through, and they were reading articles about it, they were like, well, can we do this faster? Can we do it faster? So 2026 was talked about. In the end, there was a push for 2024. And so when it was asked to the Space Council, can we do this? The answer was yes. We can technically we can do this. The question is, maybe otherwise, is it bureaucratically possible? Is it resource possible? And those are the questions we're answering right now. We're looking to see, can we make this happen? But the passion for deep space from the administration is strong, and it's a very unique opportunity. So the prize, the focus is urgency. And so you might ask why 2024? Well, that gives us an opportunity to have, within the political cycle, some focus and prioritization. And so even if we won't fall short, but say we do, then the prize is really an organization that can move in deep space again, an organization that can move forward in these grand goals. That will get us to Mars, right? So any step that goes to Moon gets us to Mars. And so the question might be, what this panel is asking is, how does a Moon landing help us with Mars? And does it enable Mars landing? Well, alone, it does not, right? I think we all know that Mars is a bigger problem, but it is a key step. And so, the key word of that is sustainable. And so just looking back to the space policy directives and the recommendations from the last Space Council meeting, it says, the goal is to land Americans on the Moon's South Pole by 2024, establish a sustainable human presence on the Moon by 2028, and chart a future path for human Mars exploration. So this is the model that the Space Council has endorsed, that NASA is examining, and we think that this is a key path going forward. So then, what other aspects of this will help us get to Mars? And I want to highlight just a few things. The first is the Lunar Gateway. It was mentioned just a second ago that the orbit was something I worked on. It is a key part of what it means to do sustainable exploration. Why? Well, because there's reusability built in. There's this station that allows us to have station keeping and safe haven. That allows us to aggregate systems. That's a key aspect. And then to follow on to that, we do believe that there should be a surface plan. How do we build from a surface plan? And so what Dr. Pace gave a speech a few weeks ago to the USRA talking about a lunar field station. And so this idea of a lunar field station allows us to do very similar operations than what we might see on Mars. So we've talked about how that's similar to what we've done in Antarctica with McMurdo Station. So these are ideas I think could be very useful. The South Pole is particular of interest because of its unique environment, the peaks of near continuous sunlight, the proximity to the water ice shadowed regions. So we think this is something that needs to be explored, and along with the Gateway, a concept that can be expanded on. So in general, if we proceed to that route, we think that this would be very feed forward to Mars. In fact, NASA has done studies to that effect, and so we think if we think carefully about what we do on the Moon, we can make sure that happens for Mars. So, thank you.
Yeah, well, it's great to be here today. I rejoined NASA just a few months ago, and when I came back on board, I was coming off of about 5 years as a chairman of an advisory group, the Human Exploration and Operations Committee, where we got to watch how NASA's plans were kind of morphing from the asteroid redirect mission back to the Moon and Mars. And that was really fun to watch. And I knew I was going to be joining NASA at an exciting time. Space Station is busier than ever. The commercial crew vehicles are getting ready to launch. SLS and Orion are getting close to their first launch. And I knew that we were going to be laying out plans to go back to the Moon. The thing that I saw in that first 6 weeks was we laid out a plan, and we were going to be trying to get onto the lunar surface with humans in 2028, which was really pretty aggressive with the budget that we were considering doing it with. And I remember being excited about everything that we had to do, but at the same time wishing we could do it faster. And I think a lot of people probably shared that sentiment. But I was happy to be on board. I just knew that the lunar landing would probably come after I had retired again. And then in March, I'm sitting in my office, and the vice president makes an announcement, and suddenly the goal line shifted 4 years. And my boss, Bill Gerstenmaier, came into the office, and he said, well, Sox, what do you think about that? Which is NASA code for how do you feel? And I said, man, I think it's just awesome. I think this is exciting. I think it's going to be good for us. I think it's going to help us change in ways that will be better for the whole agency, and it will help us not just get to the moon, but on to Mars and past Mars someday. And he smiles, and it's hard to see his smile because he's got a mustache that's even bigger than mine. And he said, "Me too." And at that point, the next question was, well, how do we do it? How are we going to accelerate this program 4 years? One of the things we thought was important was trying to maintain as much of the program that had already been laid out as possible, because anytime you make big changes, you can get into big arguments, and big arguments are slow. Another thing that's important is to make decisions. Making decisions helps you move faster, preferably good decisions. And then on top of that, we knew we were going to need more resources. And we were going to need to take a look at what we were trying to do. And so if you look real closely at the plans and how they've changed, you'll see we have changed kind of the scope of what we're trying to do. One of the biggest examples is we've allowed folks to consider only carrying 2 people to the lunar surface with a lander instead of 4. We've also allowed people that are considering providing landers to think about shorter stays on the lunar surface, perhaps pre-positioning supplies, which are all ways to make the mission easier and more affordable. But we're not giving up that much. If you think about it, if you have 2 landers, for example, and there's 2 people on each lander, that's still 4 people, and you could go to 2 different parts of the moon, which could be a super exciting mission. 2 people could stay at the gateway doing some great science while there's 2 people on the surface. There's lots of things we can do, even though we're adjusting our requirements a little bit. And by doing that, I think we give ourselves a great chance of succeeding. The third question that comes up a lot is, well, how does this affect Mars? And as the administrator said just a few minutes ago, Mars is still part of this whole plan. It's moon to Mars. Everything we do in this program is intended to inform our journey to Mars. If you look at what we're doing on the space station now, the work with life support systems to build super reliable and super efficient life support systems, the work to understand human physiology and microgravity, the work we're going to do at Gateway, especially the long lead items like propulsion development, solar electric propulsion, that is going to be critical when it's time to go to Mars. More than that, it's going to change how we think about orbits. You know, how many people here know what a near rectilinear halo orbit is? Well, it's different than the orbit we use in low Earth orbit, I'll tell you that. And the way you maneuver is going to be different, and the way we think about orbital mechanics is going to be different. And that's going to be really important as we feed forward to Mars. The same thing about the work that we do on the lunar surface, the habitat work. So I think the work we're going to be doing trying to accelerate to get to the moon is going to help us get to Mars sooner. But one of the key things I think that's going to have to happen, and you can kind of argue on the date depending on when you want to go to Mars, but at some point we're going to have to make a decision, and we're going to have to make a statement somewhat similar to what just happened for the moon. I think 2025, 2026 will be a good time to consider that for whoever is in office at that time. And it'll be a good time for us to say, hey, it's time to redouble our efforts to get to Mars. And that decision will be what focuses us and gets us to the next step.
Rob?
Well, thanks. So I was the only one that brought pictures. But once you have pictures, the rest is just details. So totally doable. Any questions about landing by 2024? I like the way John phrased it, by the way, which is an existence proof. So a few weeks ago, we rolled out a concept really to stimulate dialogue amongst all of our fellow commercial industry folks on how could this physically be done, and how could you do it in a way that's safe and sustainable, almost as a minimalist approach. So this isn't the Lockheed Martin solution, nor is this the only solution, but we wanted to move the dialogue away from can it be done to let's start talking about the best ways to do it. So with that, the requirements that we put on ourselves was first, uncompromised safety. So fast does not mean reckless. And that, to us, drives the use of existing proven systems for the safety critical aspects of the flight. And I'll talk to you a little bit about that in a moment. But make no bones about it, we're going to have to take mission success risks to do this. This is a bold exploration activity, and we're going to have to lean forward. And I think everyone can really get behind that as long as we have addressed the safety and that we ensure we're not compromising that. And then global cooperation. So as soon as you leave the Earth, it's by definition a global activity. It's bigger than one country. It's certainly bigger than one company. And so the objectives of working with the international partners, the back end of Orion comes from Europe. And that's been a really productive and helpful relationship with our European colleagues. And we really look forward to how that can help accomplish this by 2024. So for those that haven't seen this, big picture-wise, operations concept, and I would say not everybody in industry has this same architecture, but they're all pretty close at this point. So I don't think I'm going on too much of a limb to say this is where we're converging downwards. So first, PPE and a node. The node has been alternatively referred to as most recently the mini-hab. Prior to that, utilization module. Looks like a docking node, so we've called it a node. It would be great to fly that with the PPE. And so for our minimalist architecture, that's our objective in the concept. That would go out into NRHO or perhaps an alternative orbit initially, which doesn't denigrate the NRHO, but we'll talk about that in just a second. The objective that we had was absolute minimal new systems and new DDT&E and protecting for safety. So we'll talk about that in a moment. The ascent and descent stage would fly separately. NASA is currently looking to industry to get those up to the gateway and using commercial launch vehicles and the like. So the R2-D2 looking thing would be an ascent stage. The lander looking thing is the descent stage. And then of course Orion with initially 4 crew, of course, 2 down to the surface and 2 at gateway perhaps, 4 to the surface, all sorts of different options within that. But we wanted to make sure the architecture was scarred to get to that sustainable 2028 where we're doing this often. So everyone congregates at the gateway. This is really, really important. Systems engineering is hard. And large-scale human spaceflight systems engineering is really hard. When you meet at the gateway, and that becomes your interface, that becomes the get there as you need to, and you have to sync the schedules, but you're not building up systems in LEO and flying out together and arguing about who gets to point tail to sun and so forth. That significantly reduces the programmatic complexities, which is how we can divide and conquer this effort and ensure that we actually can accomplish it by 2024. So then the lander leaves the gateway, goes down to the surface, and then the ascent stage comes back up. We talk here a little bit about an intermediate orbit, and we've been talking with NASA. You can think of this as an off-ramp or an opportunity. The baseline would include a transfer vehicle, aka a tug, to go from NRHO down to a lower orbit. But what we wanted was an existence proof that you could do this without requiring the transfer vehicle, and that would allow you an opportunity if it's not ready or if you want to use it to enhance the mission as opposed to being critical path and inline. So I heard my colleague and friend, Dr. Clive, speaking a little bit earlier, so I won't try to do his chart justice. I'm going to let him talk it later. But if you see all the light blue in the center of the South Pole, that's water. Now, how accessible it is, that's why we need the prospecting. And that's why having humans there to help in the sample return, to look at ISRU, is so critically important. And the reason we just have this slide here, For us, we've been on with NASA, every mission to Mars. We've explored more planets than I have fingers to count. Well, I can't be because we only have 8. But the thing that drives the mission in the vehicle is the science. It's the mission. And so one of the things that we've been really starting to talk now with the PIs and with NASA is what are the objectives, the science and exploration objectives of the mission, so we don't get too focused on the widgets and the gadgets and the prop systems, but instead talk about what we're actually going to do, which drives everything from co-manifested payloads to the robotic precursors, for example, using CLIPS, that will make that 2024 mission very rich. And then finally, what's that path look like? There is not a whole lot of time to do a bunch of uncrewed flight tests. This is really the difference between the HLS program that we rolled out, We the Human Race, in January versus the 2024 landing. There was a 26 uncrewed full-up system, and a 28 was when we first launched the crew. So in order to do this drives the need for using existing systems, because even if you add a flight test in 23, that's really a go, no-go. You can't learn anything that you're going to turn back into the design. And as a result, you need systems that have already flown, systems that have been proven out, because this ultimately is a safety critical mission in terms of getting the humans back off the surface, or if there's a problem during descent, back to the gateway for a safe haven. And there it is, picture, so it's all done.
Right. In introducing Bhavya, there's something I should have said. The reason she's on this panel, I asked her to join the panel, is that she was one of the lead authors in the STIPI report that came out 6 weeks ago, a month ago, for NASA, that said, given the existing circumstances, a Mars orbit mission in 2033 was not possible. So the question I asked her in joining the panel is, does the acceleration of the program change anything? So.
Great. Well, thanks for the invitation, John. Actually, and John had said also to say a little bit about who we are, so I'll start with that. The Science and Technology Policy Institute is a federally funded research and development center in FFRDC that was created by Congress to support the White House Office of Science and Technology Policy and other federal agencies. We work only for the government, the US government, and we tend to be asked to do studies that are not appropriate for the private sector, so our work tends to be unbiased. And in the NASA Transition Authorization Act of 2017, Congress mandated that NASA contract with an independent entity to conduct an evaluation of a human spaceflight mission to Mars by 2033. And so NASA requested STIPI, given our reputation of being an independent, unbiased FFRDC, to do so. The important thing to say is that NASA specifically requested that we use NASA's current and notional plans for human exploration as a basis for the space flight systems and timelines presented. So I'll give a quick overview of the findings of the study and then get to John's question about how does 2024 affect things, with the caveat that the study came just weeks before the Vice President's announcement, so that was not an issue we specifically looked at. And it really is important to look at it analytically as opposed to my opinion. So just to kind of recap our method and our scope, so you know why we came up with the results we did. So under current and notional NASA plans, a gateway, as Rob and others mentioned, is a small human-tended station in orbit around the moon. It will be assembled in space between 2023 and 26. Human missions to the gateway will be launched using the SLS and the Orion crew vehicle. Again, that was one of the requirements of our project. And I guess I should say that in our entire analysis, while we do have 18 SLS Orion missions, we also have about 40 commercial missions. So it isn't exclusive of commercial missions. So that's, once the gateway is assembled in about 2024, NASA begins to develop the Deep Space Transport, which is a vehicle that would take crew from moon orbit, the NRHO, or whichever orbit we end up being in, to Mars orbit, which would be an 1,100-day round-trip crewed mission to Mars. using this general architecture, we found that a 2033 departure date is infeasible under all budget scenarios and technology development testing scenarios. So in other words, the 2033 date simply is driven by technology development constraints, not even budget constraints, which of course enter the picture and make it more infeasible. And I would hope you have a chance to look at our report, which is actually public. So you have the title of the report on the screen, so feel free to find it. So 2035 we found would be possible under budgets that match 1.9% real growth, but of course carries high risk of schedule delays due to complex technology development, testing, and fabrication schedules, especially for the DST, the Deep Space Transport. And it may require reducing the scope of lunar missions and reduce NASA's ability to mitigate risks to human health, which actually is a stream throughout our report about how much more there needs to be done to retire the risk to human health for a mission to Mars. In our assessment, 2037 was the earliest the DST could feasibly depart from Mars, assuming a small budget increase or at least smoothing of the budgets over a couple time periods in the 2030s, with 2039 being a more realistic time frame if there are delays or budget shortfalls. So that's essentially our study, and now the question is, what does the Moon 2024 do? So the couple things I would like to bring up in that context is, in our study and in NASA's notional plans, 2024 is when phase A of the DST begins. And if in 2024 we are just landing on the Moon and potentially preparing for surface infrastructure and maybe scaling up operations on the Moon or having more sustainable activities, that would definitely clash with a major part of the DST, where in between 2028 and 32 is when most of the big ticket items are being done, the fabrication, the integration, the ground testing. So that's sort of an important thing to remember, because it isn't just budgets. And again, I'm assuming here that budgets will somehow come, but it's also organizational bandwidth. How many things can NASA do at the same time? If the gateway in the first phase is a scaled down version, it is likely that in the 2024 and beyond frame, we would also be looking at maybe scaling up the gateway. Maybe if SLS Block 2 has to be delayed for early Moon reasons, we may be working on SLS Block 2, which is required for the DST. So it is unclear to us, or at least to me, not having done a formal study, how going to the Moon by 2024 accelerates Mars by 2033 or even beyond. However, it is something that we need to really systematically think through, and I think that would be something we'd like to be doing in the coming years.
Thank you. I want to thank all my panelists for sticking to time, which gives me a few minutes to say a few things. As Artemis said in introducing me, I've been at this for a long time. And in particular have looked closely at the set of decisions that took us to the Moon in 1969. And there is some parallels. Is this another Kennedy moment now? A Trump moment? But NASA had already decided to go to the Moon before John Kennedy gave it that assignment, had done technical assessments that said there were no inventions required, there were innovations required, but no technological breakthroughs. The technology was in hand, and it could be done, this is early 1961, by the end of the decade. So when Kennedy said, find me a space program which promises dramatic results in which we could win, that was his charge. NASA could come back and say, yes, we could go to the Moon. So there was a technological foundation. Jim Bridenstine said, in a sense, what's going on is an acceleration of an existing plan. That's what happened in 1961, is that the NASA 10-year plan that had said Moon after 1970 was accelerated to Moon before 1970. The first year resources were combined with the initial Kennedy increase before the decision to go to the moon and then the decision to go to the moon, plus the NASA budget, 89%. This is what, about 10%? But that was, as Jim Bridenstine said, the first step in a upward curve. The next year, the budget went up 101%. That's not going to happen. But we're a lot further along than we were in 1961 and 62 in having the capabilities to execute the mission. So, I think that there is von Braun consulted in 61, said there was a sporting chance of getting to the moon before the Russians. And I think we have a sporting chance of making 2024. Rob, you showed the mission sequence it's worth remembering that the first Saturn V launch carrying a crew was Apollo 8, went to the moon, just like EM2. So we'll see. So a question for anyone on the panel: what's the long pole? Thinking about the whole sweep of the system to do this, as it's being laid out, what do you think is the long pole?
Well, everybody probably has an opinion, but I think the lander systems are the long pole. I think that's what we need to get the procurements going on and what we need to get in place as quickly as possible. What do you think, Ryan?
Yeah, same. Especially the ascent portion of that system is definitely the long lead item. We need to have habitation capability combined with propulsion capability, and it needs to be in a form that has a high performance index. And so that's why Lockheed Martin's Orion derivation is certainly very appealing, because it's using existing tooling, existing systems to springboard that system. But it's definitely going to be the hardest thing to develop. And so you're going to have to do quick testing. You're going to have to allow industry to run pretty fast to do testing and development.
Yeah, I think I was quoted somewhere saying that we need to start bending metal next year, we, the human race, whoever builds the ascent stage, that pressure vessel, that's how long it takes to build stuff up and then integrate with secondary structure and avionics and so forth. And tooling is really long lead. As an avionics and software guy, I've just been told, and so I believe it, but it's still astounding to me. The software is going to be done before the structure this time, by the way. I'm going to guarantee that. I'd say, though, the longest pole is the predilection of engineers to optimize. So we spend 23 years minus whenever you start doing calculus, which was like first grade for me. Nowadays, my daughter, they start earlier and earlier, but we are taught to optimize, right? Calculus is just optimization of the derivative. So the problem is we are taught to optimize a problem. And if we start from scratch on, we're going to build the most greatest 2024 lander you've ever seen, then we'll never get there. And that's why we're so hard over within at least Lockheed Martin, thinking of how do you leverage what you already have so that you put the new development into the stuff you don't have.
So in my mind, again, kind of keeping my Mars background, the long pole is really human health. We do not know enough about how microgravity, isolation, and deep space radiation will interact on an 1,100-day round-trip journey to Mars. I won't even say it's a high risk. I would say we don't even know the risk. We know so little that we don't know what the risk is. And to your more direct question, the long pole, I think, is keeping political attention long enough that we will get the budgets that are needed to meet our deadlines.
As a political scientist by training, I would say the long pole is the U.S. Congress.
I would agree with that.
We went right to the technical.
Right. Well, those are the easy answers. Right. Again, going back into history, the Apollo spacecraft, Kennedy spoke in May of '61. The Apollo spacecraft was under contract by late 1961. It took another year to figure out we were going to use lunar orbit rendezvous. So the Grumman contract for the LEM was November of '62. I don't think we have that long to wait to get the lunar system. Where are we, Mr. White House, with respect to the Congress? What kind of vibes are you getting?
Positive in most part. I mean, I think folks are excited about the idea. Of course, the politics, weigh heavily on different folks' minds. So I won't speak to how everyone is involved. I think one of the big benefits of this particular budget is we aren't, pilfering. We're not taking from other portions of the budget. We're not taking from science. We're not taking from HEOMD. I mean, it's all being done in HEO with a plus up. So the opportunity here is to show that this is an and story, not a or story. You're not cutting other things. So I think that will be very appealing to Congress because we aren't in this this pigeonhole, and we're not trying to do Apollo Redux. We're trying to do exploration writ large, just accelerated.
Yeah. Well, when I look at the challenges, the political challenge you talk about, I see it as a challenge of building a team. All right, the team that takes humanity back to the moon needs to be very inclusive, all right? We need people from both political parties. We need people from different nations. We need suppliers that have been in the business a long time and suppliers who may be very new to the business. And you can go on with all the different groups that need to participate and work together to make this happen. But I see tremendous progress in that area, and I'm very positive, thinking that it will be able to be done.
That was a political question, so I'm going to keep moving it on down the line.
Talk politically.
FFRDC, any comment on that?
Go on, but then I'm going to turn to...
Yeah, in terms of speed, I mean, in procurements, that is a key question, right? So we are investigating with NASA how this can be sped up in the procurement process. So I think NASA's leaning very far forward with the BAA process, with the integrated lander synopsis that's going out. So this is a different approach than it's been done before. I think that provides another added bonus to suggest that this is possible because of a different strategy and getting to closure on procurement and releasing the money to let industry go.
Yeah, when the announcement was made that we were going to accelerate to 2024, there was already a procurement started to work on development of the transfer element, the descent element, under the broad area announcement.
Yeah, that was going to be one of my questions. Right. Even with the existing 19 budget, there's a capability to get started?
And what we're trying to do, again, is speed up existing work, and that includes that procurement. And part of what we did, we initially, right away, put out a synopsis for the ascent element. And then we issued another synopsis saying, well, it's okay to look at this as an integrated system if you want to as well, so that we could get an integrated picture if somebody wanted to consider all the elements together. We're waiting for feedback on those different procurements, and I think it's moving very rapidly.
Good. I can't see. Are there mics out there for questions, or? Well, let's open for questions. I've got plenty and nobody does. Huh? There we go.
Hello, panel. My name is Paul Armstrong, and I've got a multi-part question. Hopefully I can optimize it. Starting with the entire cycle at the moon end and working back. As an outsider, it would seem that in the approach of a ascent and descent stage lander, that one, it's single use, okay? Being single use, what do you do with the equipment, the hardware, once you've used it? And then obviously there's only so many docking stations on the gateway, so you would presumably need to continually refresh the lander or landers with rocket launches, multiple rocket launches from Earth. Obviously there's a cost to that. If you had a reusable one or more lander, then again, the budget would be much smaller. Okay. Now, working back to Earth, there's an option I had thought of that might mitigate the cost, and that would be a gateway as such, but a little bit different than what we currently have, and that would be more in the order of a shipyard that would build these landers and get them to the moon at a much lower cost.
Are you going to get to a question?
Yes. So those are considerations. Again, the working back, talk about the Earth. All this is going to require multiple launches. And as we hear, more and more countries are launching rockets for whatever purpose. And that will add to the amount of space debris.
Please ask a question.
Yes. Okay. We get to the question. Simply taking all those things into account, have they been considered, and what would you do more specifically regards to space debris due to the additional rocket launches?
You want me to take that one? So first of all, one of the things we want to do is make sure we use all of our assets, right? So we're looking at using SLS for launches, but if you look at the cost of an SLS, we're going to have to be very strategic when we use SLSs, okay? And careful about how we use them so we get the most out of those launches. And we'll augment SLS with other available launch vehicles, okay, procured commercially. Now, that will increase the launch count, and so we do need to think about orbital debris. But every one of those launches, we consider where the different parts are going, and there's a plan to make sure we minimize orbital debris on the launches. And that is considered as part of the procurement package for each individual mission.
And I'll add to that. I mean, basically, all of the launch providers and all the companies are looking at reusability very keenly. And so reusability is going to be featured in everything we do. Now, as a part of the 2024 story, I think that's still open. Like, it may be that we can reuse those systems to a certain degree, but it's all part of the goal. So yes, minimizing space debris is part of the sustainable path. Reusability is part of the sustainable path. That's why there's a gateway. That's why we have these nodes that allow us to reuse things. If we get water ice off the moon, guess what? Now we can reuse the descent element. So all those things are paths. We just have to decide from a technical level and a cost level where those things come into play.
Also, I think obviously we always want to be careful about space debris, but the space debris is a bigger challenge when you talk about, the LEO communication satellites going up in the next few years, tens of thousands of satellites in LEO. I think those are the things too that are much more of a near-term problem than, in our calculations, we have 18 SLS launches and let's say 40 commercial launches. So over 20 years, that's about 2 to 3 launches a year. Again, not to say that we shouldn't be minimizing their impact, but I think they are a much smaller hazard than the 7,000, 15,000 satellites SpaceX plans to launch, or OneWeb, or any number of LEO communication companies.
Got a question over here.
Yeah, thanks for your insights. I was wondering if you considered any public or private disruptions, such as the Blue Moon projects or SpaceX's, that could disrupt the forecasting cycles. If you look at the Marco mission with the insights, the nation state policies are transitioned with small sat integration in the ballast side. I didn't know if you guys had pulled out any of these threads in your...
STIPI analysis, I assume.
So since we were specifically requested to look at the NASA current and notional plans, we took a very straightforward, SLS Orion, supplemented by commercial, which are likely going to be reusable. I think, if I recall, we do have for the landers, we do have commercial partnerships. To the extent that was feasible, we were able to put in disruptive notions. However, we didn't, for example, the DST is to be launched as a single unit. It's a 100 cubic meter pressurized volume system, 40 metric tons or something like that, and will be launched as a single unit. So it is an option for it to be assembled in space. We did not consider that, and that would be something that we do not believe, well, A, we were asked not to, and B, we are not sure if we are ready for something like that in the next decade or so.
Ryan, were you going to say something? Okay, yes, ma'am.
Hi, hello, my name is Tatiana Indina. I'm the founder of Silicon Valley-based accelerator, Mission to Mars Academy. And my question to this panel is, we work with innovative global startups all over the world, and there are not too many of them in space tech yet, around 1,000 of startups maybe. So my question is, what do you think US government, NASA, and all other stakeholders of this mission should do, and what are you planning to do to engage global entrepreneurs community in order to accelerate tech innovation that is needed to achieve the breakthrough, the technological breakthrough to make this mission possible? Thank you.
So I'll just allude to the CLIPS program as a good example of how we're engaging small companies more directly. So the larger systems here for the 2024 landing does require some advanced systems and some resources and people that maybe exceed some of the smaller companies. But the CLIPS program, we're partnering with, NASA's partnering with 8 different companies right now who also are smaller in size and have a little bit less that overhead that these other companies have, and they can move fast and lean. So I think NASA's very keen on partnering with small businesses. In fact, that's part of the portfolio going forward.
I think if you look at space station, almost to take that CLIPS example and continue to both bring it forwards and backwards. Space station, we're at the Lockheed Martin partnered with NanoRacks and looking at who've been successful in putting up over 600 payloads on space station to look similarly at what can we do secondary payloads on Orion and on the Gateway and ultimately on the descent stage and the ascent stage as well. Those are really reducing the barrier of entry for folks to be able to fly technologies without worrying about communications and CNDH and thermal and comm. Instead, they can just fly their payload with or without human intervention in order to really move that technology forward. And so I think those really proven capabilities that have occurred on ISS are going to continue as we move out into cislunar space.
Rob, in the architecture you showed, is there any room for international contributions?
Absolutely. Certainly the back end of the Orion vehicle is built by Europe today, and so that's one of those proven systems that we think it would be really good to look at for the ascent stage, where safety criticality and there's not enough time to do a lot of DDT&E fits. But there's also other elements, for example, the transfer vehicle, which we talked a little bit about earlier, which would allow us to retain the gateway up at NRHO and to bring a reasonably sized ascent and descent stage down from that gateway orbit. That would be a wonderful opportunity to collaborate with our international partners.
As we move from lunar missions to much longer duration missions to Mars, for example, we need a life support system which is highly, highly reliable and also, in terms of recycling, much more efficient. So if we're going one way to Mars is at 6 to 8 months, and then if you land, you can use ISRU and resupply yourself. And Mars orbital mission, as you said, if it's 1,100 days, you really need a very, very highly efficient recycling of oxygen and water, and it has to be really, really super reliable. The odds are that humans will not die of radiation or of zero-G problems or anything like that. What's going to happen is that your ecosystem is just going to screw up.
So is that a speech or a question?
Yes, it was. It seems like the development of next generation ecosystems is under the DST, looks like the spending profile doesn't have any huge spending on it. Shouldn't we accelerate the development of a next generation life support system?
And I agree with you 100%. And there is a lot of work going on at NASA in that area, and there are demonstrations getting ready to fly on the International Space Station. The International Space Station is the best place right now for us to do that long lead development on the super reliable and super efficient life support systems.
Sox, let me ask you a nasty question.
Yeah.
For this program, Moon then Mars, how long do we need station?
How long do we need station? Well, honestly, for going to the moon, you need station less, okay? But I believe station and low Earth orbit services, I don't want to focus on ISS. I want to focus on the capability to get people into orbit and do work in low Earth orbit. I think we'll need that even for our trips to the moon, especially when you consider that people react differently to going into space, and it's nice to get them a space flight before you spend all that money to get them out to the moon. And then when you go to Mars, that's triply true. I think they ought to have a long duration stay somewhere.
Qualifying flight.
I would call it a qualifying flight or a training flight, and something in low Earth orbit is the best place to do that. And so I think we're going to have a mission in low Earth orbit for a long, long time. Now, whether it's ISS or whether it's something that follows after ISS depends on what your view is of the time frame, but I think we're going to need that for a long time.
Okay, we're about out of time, and there's nobody at a mic, I think. I see a hand, but we need a mic, I think. Hold on a second. The rest of the audience has to be able to hear you. And keep it short.
Your presentation made an excellent impression on me because you poured a lot of cold water on a lot of unduly optimistic assumptions using numbers. There's a great planning group at JPL that plans all these manned missions, plus I'm sure congressional staffs. Have you shared your findings with these people and compared notes?
So that's a good question. Our report is first of all, on the cold water front, I want to specifically say that there's one member of our team who is very good at pouring cold water. He's our project economist. He's in the audience, Keith Crane. So the rest of us are sort of aerospace, space cadets, and he comes with cans of cold water. Anyway, but to your second question, so we had a lot of input from NASA with respect to data and methods. So I'm assuming that we may have talked to some folks from JPL. Having said that, I mean, our report is public, and I think maybe it would be worthwhile to engage more with them and go more over our study findings. One thing that I think would be really useful for anybody to do is sort of more if-then analyses. If the gateway scaled back, or if the moon, if there's a longer sustainability plan on the moon. DST looked different. Nuclear thermal propulsion on the DST, because our assumption is a solar electric chemical hybrid system. So I think it would be useful to look at the effect of an NTP, because that reduces the transit time by 30% or longer. And everything is interconnected. So
Artemis is out here with her hook. So thanks to my panelists, and thank you all for paying attention.